crores of rupees from different funding agencies. All our research obviously leads to some publication, not a normal publication, but we focus on a quality publication. We strongly collaborate with scientists from 130 countries all over. And to give an example of the quality of publications, you are all aware that the Nature Index journals, they give out institutional output every year. During the period 1st September 2022 and 31st August 2023, 25 publications have come from SRM IST. And if you look at the ranking at India level under academic stream, we are at the 25th position. And if you take the private institutions category, we are at the second place. So we have been contributing a lot towards the quality research. And then the intellectual property rights becomes very important. As on date, close to 14 of our patents are into commercialization that are at various levels. And very soon we will have good announcement from us. In addition to a lot of Center of Excellence at SRM, recently we added 2 Centers of Excellence. One is on electronic cooling in association with Intel Corporation. And then recently, the Government of India has sanctioned 100 5G use case labs across all higher education institutions, and SRM is one among them. Now, we don't stop with teaching research. We encourage our students to become an entrepreneur. As on date, close to 30 startups are incubated in the campus, and including 4 faculty startups. 2 of the startups have graduated very well from our campus. One is working on the e-mobility. It is called as Abhinav Raisal. It has raised funds of 200 crores from a company called Forgings. And then few companies are working on healthcare, EdTech, e-mobility, and other things. We felt that our students should be exposed to what is called as a design thinking so that they can be more creative during their research or when they want to become an entrepreneur. I'm very happy to say that as an initiative of SRM, close to about 200 faculty members have been trained to deliver courses on design thinking in association with the School of Design Thinking, Chennai. Now, we are the largest institute in the country, and we are pioneer in introducing new programs. So design thinking is one of the compulsory courses for the students of SRM IST. Now, coming to this conference, I am extremely happy that 14 journals have associated with this conference, and more number of publications will come out of this conference. Close to about 100 foreigners on the campus for this conference. But going way forward, I think we should focus more on industry-inspired research. How we can convert all these lab researchers to the industry-inspired research. Unless we reach the industry, all our research may not be that fruitful. So I urge the organizers that in future we should have more participation from the industry also. So with these words, I appreciate the Nanotechnology Research Center for organizing this wonderful conference and wish the conference all success. Thank you.
Thank you very much, sir. Our Honorable Chancellor, sir, is a respected visionary for his service to the cause of education and public at large. He serves as a distinguished parliamentarian representing Perambalur Lok Sabha constituency, Tamil Nadu. He is notably supportive of enabling empowerment through education to meritorious students in Tamil Nadu. Persistent and dedicated hard work is the key to success. This is the cherished philosophy of our Honorable Chancellor, sir. I now invite our Honorable Chancellor, sir, to release the conference proceedings of AFMD 2024. Thank you, sir. Please be seated. I now call upon our Honorable Chancellor, sir, to address the gathering.
Respected Chief Guest, Dr. Aziz Ali, respected Guest of Honor, Danagar Anjilal FNA, FNASC, Mr. Vice Chancellor, dignitaries on the dais, Registrar, dignitaries of the dais, participants, I am really very happy to be here to inaugurate this international conference. SRM, probably when you think of going to Chennai, that is India, you would have got some idea about SRM. SRM is one of the pioneer institutions in India, and it's one of the largest in India with more faculties like medicine, engineering, with so many faculties. Regarding the nanotechnology, we are the pioneer in introducing this in this university. Friends, I am Parivender, founder chancellor of this university. This university is spread over throughout India in different locations. That is 5 universities are being controlled, and more than 1 lakh of students are studying in the group institutions. It's well known and popular among the students of this country. About 60 country students are studying in this university. In fact, most of the prime ministers, speakers, presidents of this country have already visited on different occasions and delivered speeches for convocation and other functions. Therefore, this actually, when I am standing here, I find a different atmosphere in the sense, am I standing in SRM University dais or I am standing in the UNO? Because so many flags are there behind me. 33 country flags are there. That means I must really appreciate the Department of the Nanotechnology who arranged this international conference. Nowadays, university doesn't mean giving degrees alone. They must always go in for innovation, invention, and possibly more of patents by which many products are coming out through the university. Because our Prime Minister, Indian Prime Minister, we were in the 10th place in financial capacity. Now we are in 5th place after he has assumed his office, Mr. Modi ji. And we are also aiming at to go for the 3rd place very shortly. So we always look for the growth and also the development of this country. That is possible only by organizing this kind of conference because there are many sessions are going to be, and in fact it's sponsored by some 10 country people, and out of nearly 170 eminent scientists are now going to present and give to the people, out of which 110 are foreigners. Therefore, you have seen that a book with such a bulkiness were given. About 1,300 papers is being received, and you are all going to discuss on that. Therefore, we are quite often, not the first time for us, many departments of this university, faculty of this department, university, conduct several national and international programs. But this is very special because nanotechnology is something that is the recent development comparing the other departments. So we are very much at it, and of course the dignitaries from other universities and countries, you will give your ideas, discuss among yourself, get some fruitful results by which the country, not the country of India alone, but countries whoever they participated, they will go with nice ideas after discussions and consultations and presentation. I am sure it's going to be very fruitful to everyone who is attending in this conference. So I am happy that I am able to be here on the day of the inauguration, being the first person of the university. I'll welcome you all to this conference. During a stay, I hope you will be really leaving with a lot of memories of the campus atmosphere and facilities. Not only our sport facilities are really very high, and also our infrastructure for the laboratories are really very much impressive. For nanotechnology alone, we spent about 50 crores for the recent purchase of equipments and other things. Therefore, I think every one of you who are here, and when you are leaving, you go with some good memories and also probably some new ideas of your friends who are going to be there in the discussions. So in these circumstances, I wish, once again I welcome that all of you be happy and enjoy this conference, and I wish you all the best. Thank you.
Thank you very much, sir. We are privileged to have in our midst today dignitaries whose accomplishments and contributions have not only shaped their respective fields, but have also left an indelible mark on a global level. I now request our Honorable Chancellor, sir, to honor Professor Ashish Lile, Director, CSIR National Chemical Laboratory, Pune, with a shawl and a memento. I now request our Honorable Chancellor, sir, to honor Professor Dinakar Khanchilal, former Director, IUAC, New Delhi, with a shawl and a memento. I now request our Honorable Vice Chancellor, sir, to honor Professor D.K. Aswal, Director, HS at EG Bar, Mumbai. I now request our Vice Chancellor, Sir, to honor Professor Kaluhiko Hara, Dean, Graduate School of Medical Photonics, Shizuoka University, Japan. I now request our Honorable Vice Chancellor to honor Professor Mohamed M. Chihimi, Research Director, CNRS, France. I now request our Vice Chancellor to honor Professor Alpha Kanaun, Technisk University, Chemnitz, Japan. I request our Vice Chancellor, Sir, to honor Professor Mohammed S. Toprak, KTHR Royal Institute of Technology, Stockholm, Sweden. I also request our Honorable Vice Chancellor, Sir, to honor Dr. Chi Cheng Chi, National Cheng Kung University, Taiwan. I request our Vice Chancellor, Sir, to honor Professor Ryo Teranishi, Kyushu University, Japan. I request our Honorable Vice Chancellor, Sir, to honor Professor Aziz Amin, Hassantou University of Casablanca, Morocco. I also request our Vice Chancellor, Sir, to honor Professor Hiroshi Masumoto, Tohoku University, Japan. Sir, I also request you to honor Professor Guillaume Morin, University of Montpellier, France. Thank you, sir. Today, we are privileged to have our guest of honor, Dr. Dinakar Khanjilal. This is the most significant moment of this prestigious event. I take great pride and honor in inviting our chief guest, Professor Ashish Lile, Director, CSIR National Laboratory, Pune, to deliver the inaugural address.
Very good morning to all of you. Respected Chancellor, respected Vice Chancellor, many dignitaries on the dais and off the dais, deans of the SRM University, professors, and my dear students. First of all, let me begin by thanking the SRM University and the conveners of this fabulous conference for inviting me here today. It's my first time to SRM University. I have been wanting to come here on many occasions. Somehow it has not happened. In a way, I'm organically linked to the SRM University because two of my fantastic PhD students have graduated from SRM University. They have come to my place. They have done exceptional research, and both of them are placed in very high eminence organizations now. Looking at them and knowing their pedigree, I have always wondered what this place would be. And today I got the opportunity, the privilege to be here amongst you today. And in the morning, for about an hour or so, I went around the place and I saw the kind of energy, the kind of investments, the infrastructure, the young students, energetic faculty, that I just went to 2 or 3 departments here and 2 or 3 facilities. But what I saw was an incredible amount of enthusiasm, energy, and the quality of research that was being done. So I find it a real privilege to be here today and a real honor for me to come and be the chief guest of this conference. Honestly, I'm stunned by the scale of this conference. 130 delegates from 33 countries across the world have come here. 1,500 delegates have registered for the conference, and another 1,500 students. So this is mammoth. We rarely see a conference of this magnitude and of this scale. Just the book of abstracts, I barely could hold it. As Sir said, 1,300 papers being presented in 8 parallel sessions. So as I said, very rarely we get the opportunity to participate in conferences like that. I wish I had registered and come and given a talk here. I think the topic of the conference today is, it couldn't have been more contemporary. The advanced functional materials and devices, the name of the conference. All 4 words here are extremely meaningful. Over the civilization of human history, material science has only advanced, right? And today the advancements in material science span so many disciplines, so many applications. So the word advanced and materials are synonymous, they go hand in hand. But more importantly, the functional nature of materials. Materials have always had some function to do, right from our prehistoric days. And so the functionality of the materials is not just research in materials, it's about their functionality. And that functionality comes when they get incorporated in devices. So as I said, all the 4 words of the name of this conference, the theme of this conference are extremely meaningful. So I'm sure that a lot of thinking happened in conceiving the very name of this organization. Material science and human civilization go hand in hand. Right from the Stone Age to Copper Age to Bronze Age, Iron Age, the age of plastics, and then the age of nanomaterials, and there's something more interesting coming up in the future. Back in about 8,000 BC onwards, Homo sapiens, human beings, started to work with materials. And the most common material that was found around them was just stone. And they learned the art of shaping the stones and giving them functionality. They used the hardness of the stone, the ability to get shaped, to put in functions. And at that time it was mostly, human beings were hunter-gatherers at that time, so they needed weapons to hunt. And stone became that material for them that allowed them the ability to hunt and survive. And eventually they figured out that there were some kind of stones which had wonderful color, but they were also more malleable, more soft, more easy to give shape to. And that was copper, and it's one of those metals that is found in its pristine nature in nature. And human beings learned to extract copper, pure copper first, and start giving it shape, and quickly learned that the fact that copper was more malleable and also lighter gave them access to using weapons over longer distances and more accurately. And copper really began the metal age, and eventually human beings learned to extract copper, to refine copper from ores as well. And that led over, after about 3,000 years, led to the next revolution in material science, which was bronze. And I think this was a disruptive revolution because human beings for the first time learned to alloy different metals. They knew about copper, then they knew about tin and a few others. They knew about gold, but they learned the art of alloying. And I think this was a remarkable discovery because when you alloy two materials, you get synergy from it in terms of their functions, in terms of their properties. Bronze gave them hardness much more than the copper and more durability than copper. And so Bronze Age came up and survived for another 2000 odd years. Human beings knew how to use iron, but iron was rather difficult because it requires much higher temperatures to purify it, to refine it. And it was not as durable because, as we all know, it rusts. But by then, having learned how to alloy things, they also learned to convert iron into steel. And that was the next huge revolution in material science. And the Iron Age survived for a very, very long time. It resulted into highly sophisticated weapons. It resulted into monetary transactions, set up institutions, and civilization really grew from there. And Iron Age was here for a very large number of time. Come the 20th century, and a new class of materials emerged. And those were polymers, or plastics as we call it. Started with 1907 when bakelite was invented. And then in 1920s, just a few years later, the first conceptual understanding of what polymeric materials were came up by Hermann Staudinger, the Nobel laureate. And it was again a very disruptive thought because people did not know how large molecules can be and did not ever conceive that molecules can be made of smaller units we call monomers, which are strung like pearls on a string to form a necklace. And as it is typical, such discoveries which were very novel were not accepted easily. But then today, we really cannot imagine to live in a world without plastics around us. We use polymers in all its forms and applications. We understand how to make polymers in very large scales. We understand how to convert plastics into materials that into applications that we use in our everyday life. So the polymer age started off in the early part of the 20th century and continues today to be one of the most important materials that we use in our daily lives, all the way from mundane things, starting from a toothbrush, to highly sophisticated things such as the composites that we use in space and other applications. It was also in the mid-20th century that the discoveries of nanomaterial happened. Now, nanomaterials were not new. Human beings used nanomaterial. I wouldn't say they knew about it, but they have been using nanomaterials since prehistoric days. The first cave paintings used carbon in the form of quintessential nanoparticles to paint animals on caverns. And if you go to Madhya Pradesh, a place called Bhimbetka, you will see some of the earliest paintings carved on stones using carbon soot, which is, as we all know today, is a wonderful nanomaterial. But it was only in the 1950s and 60s that the real discoveries of and the real understanding of what nanomaterials are started to come up. The ability to have a state of matter with a size that is in between atomic size and macroscopic size, the nano size, which gives amazing and very, very new and novel properties to materials. We all know about how gold nanoparticles, when dispersed in colloidal solutions, can give you all kinds of colors depending on the size of the particles. And so it's the interference of light with matter that can only happen at the nanomaterial scale. So the whole domain of nanomaterials came up about 70 years ago, and it has been growing exponentially after that. And the kind of things that human beings can do today with nanomaterials is amazing, right? From sensors to applications in very high strength materials. Nanomaterials are used today in all kinds of applications. Some of the largest plants to make carbon nanotubes and graphenes have now come up in the world. And increasingly more and more of these applications are going to come up initially in very strategic sectors, but also increasingly now in everyday materials that we use. But I think we should reflect back and say, where is this field going now? And to me, the next revolution that is already coming up is in biomaterials. And I think nature gives you the kind of ability to, just through an evolutionary process, to make materials that are so complex and so difficult for us to make in our laboratories. Just look at the DNA molecule. If you lay it around, it's several kilometers in length, but packed in a very, very tiny nucleotide inside a cell. How does nature do that? How do you take something which is not really very flexible at a small length scale, but you stretch it over kilometers of length, becomes very flexible? How do you wrap it around and bring it into a scale that seems almost incomprehensible? I think the most infamous biomaterial that we have all heard of is the virus. Look at the complexity of that nanomaterial. It's a quintessential nanomaterial. It is alive, it survives, it does all kinds of functions that we don't necessarily like, but the kind of functions that are there because of the structures of these biological materials are just mind-boggling. And so one of the challenges today is, how do we understand these materials? How do we understand their complexities from atomic levels to the full size of these structures, to nanometer levels? How do they self-assemble? What are those molecular interactions that cause them to self-assemble in such fancier ways? And it's that self-assembly that gives them properties that are absolutely and truly remarkable. Can engineers synthesize these materials in the labs, achieve that kind of complexity in structure and function? And what can we use them for? How can we use biology and our understanding in basic chemistry, physics, and engineering to be able to make these very, very complex materials? And what is the best thing about these is they are all made at ambient temperatures. You don't need very high temperatures, don't need fancy solvents to make them. You just use water, you use at room temperature, and you use some fantastic catalysts, we call them enzymes, to synthesize these nanomaterials in labs which are cells and bacterial cells and yeast and so on. So nature over millennia has evolved these amazing techniques to make the next generation and most complex materials. And I think the next revolution in material science, which has already started but will grow, is our ability to design materials using biology. And I think this really brings together in a truly multidisciplinary way all the sciences and all the engineerings to come together to make these fantastic materials. But it also brings us to more complex problems of ethics, of sustainability, circular economy, and so on. And I think increasingly the focus of our civilization in this age, having understood that materials which are made and then used and thrown away is not possible, because we have very limited resources on the planet we live, and we have only one planet. And therefore, making materials more sustainable, making materials more circular in their use is really the next path that we have to forge in this materials world. I think I don't want to elaborate on this because you are going to hear some exceptional talks in this conference. I wish I was here to attend many of those parallel sessions, and I must say that for delegates it's going to be rather difficult to move between 8 parallel sessions to try to hear so many wonderful talks. So I wish all the delegates a fantastic 4 days of learning from the world's best experts who have converged here. Listen to their talks, learn a lot, and carry back with you some important messages in material science. And I hope that once you go back, you will be able to not only make new beginnings in your research and make new discoveries, but also connect to scientists and professors who have come here from all corners of the world and from corners of this country, and hope that this conference makes a more connected community of material scientists. So my best wishes to this conference and all the best. Thank you so much.
Thank you, sir. It is our privilege to have our guest of honor, Dr. Dinakar Kanjilal, former Director, Inter-University Acceleration Center, New Delhi. His presence today testifies to his commitment and interest to be part of this event. May I now call the guest of honor to enlighten us with his words.
Good morning, and Honorable Chancellor, Vice Chancellor, Pro-Vice Chancellor, dignitaries on the dais and off the dais, and large number of researchers from India and abroad, scholars, postdoctoral fellows, and young students. It is a good opportunity to attend this function, and it is very important occasion, as I see, going through the program, which is meticulously prepared with large number of experts giving talk, interacting with other researchers, and one particularly advanced functional materials. Being connected with the research, active research field for nearly 4 decades, I have seen many new ideas, new things coming. The advanced functional materials, came as a functional material. The question was there, all materials have some function, what is so great. But they have some inherent functions which could quickly be translated to societal benefits also, along with deeper scientific aspects. So it made its name, made a series of journals in the name, and it is making its impact, big impact. And we have seen the high temperature superconductivity also came. Initially, it was not much useful. Now it is being used every spheres. I started working with laser materials. It is everywhere. And when new materials comes, they stay. It is not that they have gone. New ideas, new concept comes. Science goes deeper into the scientific aspects of it. Physicists, chemists, engineers, they collaborate together in large scale to have the societal impact going everywhere, from energy to biotechnology to bioengineering and sensors going for biotechnological devices. So devices as connected, I consider sensors also part of device. So it is connected with the science part. That is the beautiful, and it is being organized by the Nanotechnology Research Center. Nanotechnology also, as we know, its concepts, science is existing from 1950s onwards. But it came with a big bang when we could manipulate in atomic level the materials and could see in direct space. In direct space, we have been seeing from X-ray and XRD pattern, all those things. But finally, in space and like that, directly we could see locally. When STM was developed, AFM to manipulate and see it. And those are the discovery got Nobel Prize immediately, within 1 or couple of years. Similarly, high TC materials, when it came, it could be functionalized, it could be made more useful over time by pinning the defects so that in high magnetic field, it doesn't collapse, superconductivity doesn't collapse. So advanced materials also has a long checkered history, and it is going to be dominating for quite a few decades and will ever be present. But we have to look forward also for particularly young students. This knowledge will translate to another few years down the line. You will see quantum materials, quantum sensors, quantum computing, because it needs to side-by-side cryogenics developments are also taking place. Materials manipulations and nanoscales are now getting settled. So quantum materials will have quantum jumps in every field. We know only quantum computers, which already made a jump by the order of 10,000 times faster. It is by this end of this decade, it is expected to be a million times faster. And eventually another couple of decades, the way it is scientifically predicted, so it will happen, that billion times faster. I have seen, particularly in my life, we started with transistors, or I had some in 70s that vacuum tube switch transistor, hybrid circuits. And then we go into chips, ULSI, up to VLSI, ULSI, all the steps, and put in quantum devices. So it is a very enjoying thing to be associated with science and technology, work in a big group. And all disciplines of science and technology together, when we work in a bigger group, we see a big thing happening. And society benefits to the society actually drives the research. So that is also one part we should not forget. The quantum spin liquids, already it is staying, it is being used, but it needs more distance in having the coherence and all those things getting established over time. So this is a timely conference, and it is taking us in the correct directions. So my message to the younger researchers, keep your mind open, understand basic science, interact with technology, basic technology, work slowly in a bigger group. Because everything one cannot do today's competitive environment, but we have specialized knowledge in particular aspects very deeply, and other respects. And this university, I find, I have been seeing it for quite some time. It is coming up fantastically. It is, as you heard already, I will not repeat it. It is having big impact nationally, internationally. And I particularly see one aspect which I find the project proposals, scientific proposals coming from here, they are more focused, more deeper, and getting appreciated nationally, internationally. Thank you.
Thank you, sir. It's time to turn our attention to a moment of recognition and appreciation. Now I kindly request a Registrar Sir of SRM IST to announce the special awardees of AFMD 2024 and read the citations, followed by our Honorable Chancellor Sir will be presenting the awards. Now I request the Registrar Sir to read the citations. Kindly, sir.
Good morning. I'm happy to read a brief note on the achievements of the awardees. The first one is the Lifetime Achievement Award goes to Dr. Dinagar Kanjilal. Dr. Dinagar Kanjilal is a Raja Ramanna Department of Atomic Energy at Inter-University Accelerator Center, IUAC. He was an ex-director of IUAC with a career spanning 46 years, showcasing expertise in condensed matter physics and material sciences, accelerator physics and technology. Dr. Dinagar Kanjilal, a versatile scientist, excels in condensed matter physics, material science, and accelerator physics. Over 3 decades, he developed world-class accelerators, notably the Pelletron Accelerator Facility at IUAC. Joining IUAC in 1985, he spearheaded the development of India's largest tandem accelerator. His research focused on material modification using energetic ion beams and expanded to include superconducting, LINAC, and ion implanters. Mentoring numerous researchers, He has over 500 publications in SCI journals. Dr. Kanjilal unremitting efforts in accelerator physics earned him the prestigious Lifetime Achievement Award, honoring his substantial contributions to scientific advancement and infrastructure development.
I request the Chancellor, sir, to present the award to Dr. Dinakar Kanjilal.
The next is Dr. Dinesh Kumar Aswal for AFMD Outstanding Researcher Award. The next is Professor Kazuhiko Hara for Outstanding Researcher Award. Please.
Thank you, sir. Kindly take your seats. Gratitude is a wonderful way to draw more beauty into this inaugural function. I now request our convener, AFMD 2024, Dr. E. Sendil Kumar, to deliver the vote of thanks.
Esteemed dignitaries on and off the dais, co-organizers, delegates, participants, fellow colleagues, and student friends, it is with immense joy and gratitude on behalf of the organizing committee of AFMD 2024, I stand before you to express our deepest thanks on this momentous occasion. It is an honor and privilege to extend my heartfelt gratitude to the distinguished personalities who grace this occasion with their presence. We are profoundly grateful to our Honorable Chancellor, sir, for his presence, inspiring speech, and wishes. Thank you, sir. I sincerely thank our Vice Chancellor, sir, for his unwavering support in organizing this conference. Without that, we would have not witnessed this historic event on this day. Thank you, sir. I record my gratitude to our esteemed chief guest, Dr. Ashish Lile, Director, CSIR, National Chemical Laboratories, Pune. Our special thanks to our guest of honor, Dr. Dinakar Kanjilal, former Director, Inter-University Accelerator Center, IUAC, New Delhi. Our heartfelt thanks to Professor Mohamed Tab Chegimi, CNRS, France, and profound thanks to Kazuhiko Hara from Shizuoka University, Japan. Sincere thanks to Professor D.K. Aswal from BARC, India. And thanks to Professor Olfa Kavan from Technical University Chemnitz, Germany. And thanks to Professor Chi Cheng Xiu from National Cheng University, Taiwan. And Professor Rio from Kyushu University. Professor Aziz Amain from University of Morocco. And Professor Kassisu Masuma from Toku University, Professor Guillaume from University of Montpellier, France. And a special thanks to our registrars, sir, for ensuring his utmost care in all our efforts to make this event in a very successful way. And we thank our Dean College of Engineering Technology, Professor T.V. Gopal, for his continuous support. We sincerely thank Professor Napoleon, Dean Research, for his special guidance and support. And a special thanks to our beloved Dean Sciences for guiding us, motivating it, and driving to make this event in a very successful way. Thank you, sir. And we are very much honored and grateful to our sponsors and partners, co-organizers, who have generously supported AFMT 2024. And we have special thanks to Science and Engineering Research Board, SCRB, DST, Government of India, for supporting this event. And we have our platinum sponsors, Solaris Computers, HP, Syscon, Geol India. And we have gold sponsors, Cineco Technologies, Advanced Rico, IBGA Instruments, Printography, Biologic, and sponsors International Society of Electrochemistry, IOP, UK, Taylor and Francis, Surface and Interfaces, Fuji Electronics, SBD Laboratories, NETS, Linsize, Code Tantra, Anatech Services, Hallmark, RJ Instruments, Metrom India, First Line, Datatech, Unica Technologies, LabCard, Tosniwal Brothers, Nanotech, Rana Industrial Gases, Resmi Scientific. And last but not least, we sincerely thank the present media for supporting us with this event. Once again, on behalf of the AFMD Organizing Committee, I extend our deepest gratitude to each and every one of you. Thank you very much for being part of this historic inaugural function, and I hope you will enjoy this 4 days event. Have a great day. Thank you very much.
Thank you, sir. Let us rise for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
Thank you all. Kindly wait for a few announcements. High tea will be served at the entrance of the auditorium. I request the participants and the delegates to join us for high tea. After which, we will have 8 parallel sessions. 6 sessions happen in School of Biotechnology and 2 in Mini Hall 1 and 2 respectively. These sessions will happen shortly in the respective venues. Thank you.